Aloha, my name is Joanna Filipoff at the Curriculum Research and Development Group at the University of Hawaii at Manoa's College of Education. I'm here with my colleagues to talk about our paper, Chemical Solitaire, Arranging Cards to Build an Organizational Model of the Elements.
So this activity takes an historical approach to learning about the periodic table, but what's really unique about the activity is that it doesn't have students attempt to exactly recreate Mendeleev's work. Instead, it has them use the same kind of information, but look for patterns in order to develop their own model. Something else that's really unique about it is that in between each step, students collaborate, they discuss, they communicate, and they revise and refine their model based on new knowledge. I think one thing that's very interesting about this activity is it really pulls in the different aspects of literacy, communication, mathematical practices, as well as the practices, the core ideas, and the cross-cutting concepts of NGSS.
I used this lesson as an introduction to chemistry for my marine science students who had no prior knowledge, and I wanted them to kind of look at the cards that were in the packets and decide how they wanted to arrange them just based on what they saw on the card. So some of them used valence, some used solid, liquid, and gas, and other things like that. I found that the older students who had prior chemistry tended to stick with the periodic table without really even being conscious of it. They tried to arrange the elements in rows and columns. But overall, it was a really good activity for them to review their knowledge and to really think about why the elements are arranged this way. And they were able to look at it in a different way than they had previously done. So I thought it was a really good activity for all of the students that I tried it out with, and I really recommend that you try it.
We haven't only done this activity with students, we've also done it with teachers in professional development. We recommend that you try all of this activity before you do it in your classroom, so you can recognize your own prior knowledge and step into the shoes of your students and think about how they would look for patterns in the elements. In this way, we hope you experience the nature of science, that scientific knowledge is based on empirical evidence, that it changes over time in the light of new evidence, and that it's a human endeavor.